What's up, guys? Happy Tuesday. Um, we are going to go from circles, the circles part of geometry, to moving into other aspects of geometry. Now, keep in mind, these are things that I know that I taught a lot of you guys last year, but we're just gonna like add on that seventh grade sauce to it. So make sure that you, one, have your notebook out, you have your pages titled with notes and today's date. If this is the math section of your notebook, then you don't have to put math on there, but if it is, if you don't have a math section, then this is the part we're gonna write like math, notes, your date is on there. Today's lesson is all about parallelograms, and we're gonna be finding the area of parallelograms, okay? So pick up your thing that you're writing notes with. I'm gonna go through some examples. I'm gonna teach you guys some things, and then we're going to do a couple of like example problems, and then I'm gonna release you to do the rest of this on your own. I'm looking for how many perfect exit tickets we can get today. So do not disappoint me. Okay. All right. First things first, I have to go to share my screen. Where am I at? All right. So here we are. Ignore that part. When we're talking about parallelograms, our main focus is just finding the area of a parallelogram. The area of the parallelogram has the exact same formula as like a lot of things you guys are used to, like squares and other kind of quadrilaterals. The way that you find the area of a parallelogram is area equals base times height, or A equals B times H. And the key vocabulary you guys need to know for this is what a base is. A base we define as any side of the parallelogram that forms a right angle. So what you notice about a parallelogram is that it has four sides. We're going to talk about how you can identify the base in each of these. And then the height is the perpendicular distance from those two bases. So if you're looking at this image that we have, this example of a parallelogram, I'm actually going to like go back out into my example where here I have a parallelogram, and you can see that the base is going to be at the bottom and at the top. Not all parallelograms will have the base at the bottom and the top. The way that you'll be able to tell is if you're to draw a line from the two bases, you should be able to form a right angle between those two. You know that it's a right angle. Sometimes in your diagrams and practice problems, you'll see that it's a right angle because it'll have like that little box. You know that that's a right angle. That's how you know that these are your bases. And then the height is the distance between those two bases. We're not going to worry about what the length of these sides would be. It's not going to be like important for finding the area of a parallelogram. What you need to know is the length of your base and then the distance between those two bases. All right. So base, and then this line is height. And so what we do is when we're looking at those diagrams for parallelograms, we are getting very familiar with just one, identifying our base, identifying our height, and then plugging that into our formula. So back into the classwork packet, here's what it looks like. Mr. Zellman wants to put 1 foot by 1 foot tiles on the bottom of his brand new pool. His pool is shaped like a parallelogram. The base of this pool is 8 feet and its height is 9 feet. How many tiles does he need for this pool? This is a super easy problem, like just like a really a bare base problem. Okay. I almost dropped my thing. Okay. So what we know is that the base of his pool is 8 feet. So if we were to like label just even this parallelogram that we have right here, we know that the base would be 8 feet. And then this blue line for height would be 9 feet. And to find the area of that, we would just say base equals, area equals base times height. Write the formula first, and then you plug it in. Area equals base of 8 times height of 9. And then we know that that is 72. Our area is going to be 72 square feet. Do not forget your units. If you just put 72, I'm going to mark it wrong because you left your number naked without any units. If you just put 72 feet, I'm going to mark it wrong because you should put 72 feet squared. When we're talking about area, it's always units squared. It's always going to be units squared. So in this one, it is 72 feet squared. All right, let's go back to the rest of the packet and look at another practice problem. Oh boy, stop that. Let's try this again, ladies and gents. Okay, so we have 72 feet there. Let's look at like one or two of these level 1 problems. If you want to find the area of the parallelogram, you know that your base is going to be 8 and your height is going to be 7. A rookie is going to make that mistake and do 8 times 6. This is not your height. 7 is your height. You can tell because it's the distance between this base up here and this base down here, and that's what you're multiplying. 8 times 7. And when we do 8 times 7, you should see your answer somewhere in here. I'm not going to give it away for you. Same here. Base is 10.3. We can tell this is the base because it's perpendicular. It has a perpendicular distance from the side across from it. These two, if we were to draw a straight line, does not form a right angle. I'm actually going to come out for a second so that we can see what that looks like. Let me erase inside of my parallelogram for a second. Oh, man. I dropped my pen. Back. All right. This parallelogram. You know that this is the base because we can form a right angle between these two bases. But if we try to do that here, there is no box that would be able to be formed. We could put a box here, but it wouldn't perfectly be touching. If I put a box here, the box is going to go outside of the parallelogram. If I put a box here, and obviously that's not a perfect square, but they would be like, it's tilted and it's not touching this line. It just looks weird. So we know that this is not an example. These sides are not these sides are parallel, but they're not perpendicular. So those are not our bases. Our height is that blue line. You guys should be able to crush this lesson today. This is like a really slow walk into what we'll be doing and just building on our geometry skills. Again, I'm gonna open up a comment section in our classroom for this lesson. So if you have questions, you can post them in there. Maybe somebody else from the classroom will be able to like chime in and help. I'll be looking at it from day to day to just like answer any questions that you guys put in that message thread, and we'll be able to stay in touch that way. Happy spring break. Love you. Miss you. Peace.